Hi, in this video I want to explain how to use this tool. Basically, I wanted to run some learning algorithm on my own handwriting, uh, something like we did in the last two homework, and the problem was how do I get my handwriting into Octave. So I built this tool just for that. So the first step that you have to do is download the tool. You can take the tool from GitHub, either download the source code and build it yourself. This is .NET 4.5, or you can just download the binaries from this directory here. You have all the binaries that you need. Second step is to download this input-sheet.doc. Basically, this is a Word document with grid, so it will help you to put the letter of your handwriting in a good format for the tool to understand and extract. So in the first row you're going to put A, B, 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 C, 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 and so on. That's it. Once you are done, you're going to print this page and scan it. So this is my page. This is my handwriting. Now, after you scanned the page, I recommend that you crop the image to fit just the area where your handwriting is. So I don't know, it depends on the scanner maybe, but my scanner scanned a lot more than this A4 page. So I had to crop it, and so this is the third step. And now we can run the tool. So this is the tool, this is the exe, and what we do here, we have this input image. This is the scanned image. So this is my handwriting. You put here, you choose the file and click on the process. What happens here? I use an image processing library. This is aforge.net. This is a free library which is quite cool, and one of the features of this library is blob recognition. So what it's doing is trying to separate those areas where this is a block that is different from the background. So if you put everything in one line and more or less with a space and correctly, there should be no problem. You should recognize all the letters separately. So the red rectangle, this is the blob, and what you see as this green area, this is the tool trying to identify the rows. So when all this info is going to get exported into a matrix, he need to associate each image with a letter. So this is going to be the Y vector. So when he's going to do the import, he will take the first row, or what he thinks the first row is. I'm going to export the first row and give all the images 1 as the Y, and then it's going to give 2 for the second row, and so on. So again, if you use the input sheet and your letter in a straight line, more or less, the tool should have no problem recognize the rows. Now I want to go over the options here. So once you verify your rows recognized correctly, you can uncheck this show rows options, so it will be easier on the eyes. The blob recognition process is working on a binarized image, which means a binarized image is only two color, black or white, not a grayscale image. So in order to binarize the option, we need to use some threshold, which will be the separator between black and white. By default, this is 200. This value is between 0 and 255, where 0 is black, 255 is white. So 200 means that any pixel that is above 200 is going to be white, and below 200 is going to be black. Now when you're putting when you're creating your the document, it's recommended that you use a white page with a black pen, so it will be easier for the binarized. Once the binarized is done, the background is white and the letters are in black, and then I inverse the picture, so the background is going to be black and the letter is going to be white. And this is the show binarized image checkbox. It just lets you show it shows you the binarized picture. Now why do you want to see the binarized picture? Because this is the image that the blob recognition is going to work on. So if your blob if you have a problem in the blob recognition and you want to see why, so you need to work with this image. Now next we have few settings that are for the merge process. What is the merge process? Blob is just anything that is not a background. So for example, in this A letter we can have many blobs. A merge process is where I'm going over all the blobs, and if I see two blobs that are intersecting, I merge them into one blob. So this is those settings. So in order to explain what the settings are, I'm going to put everything here in 0 and reprocess the image again. So now you can see we have much more blobs, like those little one and this one and those. So the first process in the merging, in the blob merging, is getting rid of all these little blobs or artifacts. This is done by the pre-merge filter size. The default, where I put it in 10. Basically this is the area of the blob, I mean 8 times the width. So if the blob size is less than 10 pixels, I'm going to filter this blob out because probably it's nothing. So we put it in 10, we do process, and now we got rid of all these blobs. So this is the pre-merge filter size. Then we have the height and width merge. This is basically for the I and J letters, because you can see that the J, the dot above the J and the dot above the I are considered to be two different blobs because they do not intersect. I mean, this I seem to intersect, but probably because of my intersection algorithm, it means this. So basically, in order to make two close blobs to merge, we need to inflate them a little bit. So this is the merge height and width merge sensitivity. So if you put it on 10 pixels, it's going to inflate each blob by 10 pixels and try to see if you get a merge. If you get a merge, it's going to merge the two blobs. So we put it in 10, we process the image again, and now you can see that the I and the J got merged correctly. We still got this J and this J who didn't get merged, although after we inflated those two blobs. So one way we can say, okay, let's give it a little bit bigger inflation. So let's do, for example, 20 pixels, and now you can see that the J got correctly merged, but we have a problem with these G and H, which are too close, and when we inflated them by 20 pixels, they got merged. So this is not good. So we can try 15. Let's go again to this area. So we are okay on the G and H, but we still have this J that's not got merged. So we'll handle it later, because first what we want to do, we want to filter those medium-sized blobs. So we have this blob here, which is nothing, and we have this blob, which is the dot of the J. So first we want to get rid of those. We don't have any more medium-sized blob. I mean, we got rid of all the very little blobs before in the pre-merge filter. So now we have the post-merge filter. The post-merge filter you can have a relatively large value, because now you want to keep only the letters. So I put it on 100. Again, this is area of the blob. So any blob whose area is less than 100 is going to get filtered. So we run the process again, and we got rid of that non-letter blob, so it's not a blob anymore. And if you go to J, we can see that we got rid of the dot, the J's dot. So what we can do in order to fix this J, we can go to the edge of the blob and we get this resize arrow. So we take and we fix the blob. So it will take the entire J letter, and that's it. We can move blobs around if we want. So for example, if you click on a blob, it will get selected. You can see it's in bold and you have one blob selected. You can select many blobs, and if you click on no area or no blob, they will get unselected. So for example, we can select this K and we have these arrows where we can move it around if we want. So basically the goal of all this thing is to get the blobs around the letters, because this is what we are going to export. Once we are done with that, we can go back to our original image, and we are more or less ready to export. So let's look again on the rows, and we see that each letter has its own row, so we don't have a mix. So it's okay, and let's get to the export. Oh, one more thing. If you want to delete a blob, I mean, if it's a big blob that it's not and it's not a letter, and you don't want to put a large filter here, because it will filter good blobs, the letter blobs. So we can just select a blob, hit right click and delete selected. This will delete the all selected blobs. So make sure that you have only the blob that you want to delete selected. Output. So now we will put a file name that we want to export this all the blobs to, and we have the image size that we are going to export, so it's going to be 20, and that's it. We are ready to export. Now by default, this value here, the extracted back color, is going to be 0, and when you will try to export, it will give you a warning that the extraction back color is black. Do you want to continue? So what is this thing? Because we need to export square images, 20 by 20 or whatever you put it, in any case it's going to be a squared image, we need to square the blobs. So for example, if we take this D, we can see that it's taller than the height is bigger than the width. So when we're going to export, we're going to take this blob and make it a square. So we are going to do something like this behind the scenes, and this added area is not going to get extracted from the image, because it's being done on a new image that I've created. So we need to put some background color on this area. So we want to use the same background color, and because this is more or less, the background is more or less the same color, so we just click anywhere on the background and it will put the background color value in here. So you can see it's 235. If we hit here it's 237, 236. It's more or less the same color, so it doesn't really matter where you click. So now we have the background color for completing the blob, for squaring the blob, and we can export the blobs. I already exported the blob, so okay, overwrite. That's it. This is data.txt. This is the exported file, and you can see this is like we did on the homework. It's taking a 20 by 20 pixels and it's unrolling it to one vector of 400 pixels. So we have 400 values here for each blob, and at the very end, at the last column, this is the row index. So the green rectangles that we had, so this is going to be the Y value. So basically we have 401 columns in each row. So this is 1 is all the A's, 2 is all the B's, 3 is all the C's, etc. So the next step is to go into Octave. What I did, I created a script. Now, let me find it. Okay, here's my script. I call it ml-ocr. Basically, I just took the ex3.m, the script that we use at exercise 3. You can see here, and it's the same script for running the model. This is the logistic regression model. It's not the neural network. So the only thing that I had to change is the x, because now our data, so we are going to load our data file, so this is the path, and our data contains both the x features and the y, the target variable. So x is all the rows, and we take all the columns beside the last column, so this is from 1 to end -1, and the y is going to be vector, which is all the rows and just the last index, so the end. So this is x and y, and then we have this randomly select and visualize the data, and I put lambda at 0.5, and then we call to the one versus all algorithm, which is the logistic regression. I also changed this one to have 100 iterations and not 50 iterations, so you can change the script, and then it's doing the prediction. And the final step is if you remember, the one versus all returns this all theta, so this is the model parameters. So I save this model parameters to an ASCII file. I put it here as ctmp learned params. So this is my script, and let's run it. Okay, so my OCR. So it's loading the data because it's text file. It's taking a while, longer than the binary file that we got in the homework. And okay, it is done. You see 100 iterations, and this is the visualization. So this is the exported data, and we are done with Octave. And if we go to our TMP, we have this learned params. If you look at the learned params, this is what we expect. We have 26 rows for each 26 rows for each class, and we have 400 parameters, 400 columns, because we have 400 thetas in each model. So this is it, and now we are going back to our tool, and we can load our model. So we can choose a file, and this is under TMP learned params. Now it is important, if you close the tool and open, so this extracted background color is going to get 0 again, and when you load the model, it will give you again a warning that the extraction back color is black. do you want to continue? So for example, let's continue, and you can see that it gathered predictions. Now this is the training set, it should fit perfectly. You can see that it got it all wrong, because now when we take each blob and make it a square, the background color is black, so the model doesn't fit. So what we need to do is just again click anywhere. You don't have to use the exact same color that you used for the learning. I mean, anything in around this area is okay. So 235, and you can load the model again, and now you can see that the model fits perfectly to the training set as expected. So this is it, and finally let's see if the model can recognize letters that it didn't see. So I have another image which is a sentence. You can see that the letters got merged here because they're very close to each other. So we go to the with merge sensitivity, we set it to 0 and scan again, and now each letter got its own blob, which is okay. And let's load the model and see the predictions. So the word D got perfectly predicted, Q got confused with Z, U got confused with O, I, C, K, okay, brown, okay, fox, okay, jumps, so U and K got confused, over we got C and E confused, E and T got confused here, lazy, G and Y confused, and dog is yog, D and Y got confused. Now if you hover a blob, you will see the predictions values, the top three predictions. Now for some reason the screen capture tool that I'm using cannot record the tooltip, but believe me, there is a tooltip here. And remember, we are running 26 classification, and we are choosing the highest classification. So in the tooltip you will see the top three classifications. So even for example here, U and K got confused, U is the second classification, and here E and C got confused, E is the third classification. So among 26 classification, almost all the right letters got in, beside D. Here D is not in the top three. For some reason they really messed up with this D. So that's it, that's the tool. It's open source, obviously you can do whatever you want with it, and hopefully you can make it better. And yeah, have fun. Thank you. Bye bye.